Welcome to this video on benthic impact assessment and monitoring for cages and suspended marine mollusk systems. We will explore how aquaculture farms using cages and suspended mollusk systems interact with the benthic zone, the importance of monitoring benthic status around the farm, how to calculate acceptable benthic status, and what competencies are needed for sampling and testing according to the ASC methodology. The benthic zone, or the bottom of a water body, plays a crucial role in the aquatic ecosystem. It serves as a habitat for diverse marine organisms, contributes to organic matter breakdown, and helps in coastal sediment protection. Aquaculture activities have an impact on this delicate environment by releasing, for example, heavy metals and organic material. When waste deposition exceeds the environment's natural capacity to decompose or manage it, harmful ecological changes can occur. Think of oxygen depletion, increase in animal diseases, shifts in the benthic microbial community, and a decrease in water quality, all of which can jeopardize a farm's operation in that area. The extent of the impact of aquaculture on benthic zones does not depend only on waste levels but also on water body characteristics and the benthic microbial community's decomposition ability. That's why it is essential that each farm regularly monitors the benthic ecosystem in its production area. The ASC Farm Standard sets specific requirements regarding benthic monitoring methodologies, sampling methods at different assessment levels, competency requirements for personnel conducting sediment sampling and analysis, and calculating the benthic ecological quality status. For cage and suspended marine mollusk systems, the ASC method for benthic monitoring requires sampling at predefined zones based on the proximity to cages or suspended mollusk systems. To visualize this better, we will use some pictures based on cage culture. As you can see on the screen, Zone 1 is the closest, and Zone 3 is the furthest from the culture site. Samples must be collected from each of the three zones during defined sampling timing. The method is based on a three-level approach in which a site conducts increasingly more detailed benthic monitoring if the results of the previous level do not demonstrate an acceptable benthic status. Sites may decide to start monitoring at any of the three levels. Let's look at this in more detail. Level 1 and 2 focus on abiotic sediment samples to analyze levels of redox potential and total free sulfide. The main difference between these two levels is the transect alignment and number of samples to be collected. For Level 1, in the case of cage culture, sediment samples must be collected at the three zones and the reference zone from a single transect aligned with the predominant water current, as you see in the example in the picture. For Level 2, sediment samples must be collected from three additional transects to capture a broader environmental impact, if results from the Level 1 assessment do not demonstrate an acceptable benthic status. If a site does not demonstrate an acceptable benthic status at Level 2, Level 3 monitoring must be conducted. For Level 3, sediment samples shall be collected in duplicate at the sampling locations outlined for Level 2, at a minimum, on the two transects in the direction of the predominant current, but the samples are analyzed for three biotic indicators, chosen by the site among 14 possible ones listed in Appendix 7, to assess the benthic macrofauna community. The same sediment samples collected for Level 1 or Level 2 sampling can be used for the analysis required by Level 3 sampling. This stepwise approach is meant to ensure an accurate impact assessment. As mentioned, the farm can choose to start the benthic status assessment at any of the three levels, to maximize efficiency. If, for instance, the farm is required to collect and analyze biotic samples by local legislation, it can conduct a Level 3 assessment for ASC certification too, without the need to test first at Level 1 or 2. Accurate sediment sampling is critical for meaningful data collection and benthic impact assessment. The ASC Farm Standard gives clear guidelines regarding the following. Sampling and analysis must be conducted by an independent, competent, and qualified person who complies with regulatory requirements as applicable. Performing in-field analysis for Level 1 and 2 assessments should be done by using specialized equipment according to the sulfide UV method or the sulfide ISE method. Farms can choose either of these methods until May 2027. From then onwards, only the sulfide UV method will be allowed. The farm shall report the benthic status to ASC, according to ASC data submission procedures. Let's now look at what happens with the results of the benthic samples analysis. The method for benthic impact analysis adopted by the ASC Farm Standard uses 5 benthic ecological quality status categories. This scoring framework considers various benthic indicators and assesses benthic health based on geochemistry and macrofaunal density factors. With the results of the samples collected across the different zones, the farm shall calculate the ecological quality status score for the benthic status of each sampling zone, following the steps outlined in Appendix 7 of the ASC Farm Standard. If, at the end of the calculations, the site meets the acceptable benthic status, it is in conformity with the ASC standard. Otherwise, corrective actions must be taken. In conclusion, the benthic zone supports biodiversity and provides critical ecological functions, including waste assimilation and food for wild species. By monitoring and protecting the health of the benthic zone, you can ensure that you are farming responsibly and helping to protect our ecosystems.